So they want us to create a linear inequality, right? Inequality for both constant and linear terms on each side that has corresponding solutions. Okay, so what we can start out with is we have the answer to this. We're going to call this variable x, and x is greater than 8. Okay. Now, we can expand this inequality and make it a larger question by whatever we do to one side, we do to the other. So essentially, I can decide if I really want to have to add 5 to this side and add 5 to this side. In which case, the inequality then becomes x plus 5 is greater than 13. Does this idea make sense? Okay. Same idea if we were to subtract something or multiply through. Say I wanted to make this a larger equation, so I've decided to multiply everything in the equation by 2. We can get 2x plus 10 is still greater than 26. Everything is still true, and when we go to solve for x, x will still be greater than 8. Now the only time, have you guys learned about when this sign will flip?
Yeah, when you divide by a negative.
Or multiply. Yeah. Whenever we multiply or divide by a negative, so let's say in this case we've decided that we're going to divide this by, we'll say negative 3. We'll just leave it in fraction form. Okay? So we're going to divide by negative 3. What ends up happening is we have 2 x over negative 3 plus 10 over negative 3 is less than negative 26 over 3. We end up flipping the sign to keep the inequality true. Okay? Those are essentially all the rules to inequalities.
Wouldn't the 3 under the 26 have to still be negative?
Whether this is negative on top or negative on
sorry,
bottom.
I totally forgot that there was negative 26.
There's one on the 26, so it's the exact same thing. Sorry, I wrote it on the bottom.
No, it's okay.
That's all there is to creating it. Now this is, in terms of a linear function, this is linear. Okay, we have a constant rate of change, which is rise of 2 and a run of negative 3, right, in terms of linear. And rate of change is constant. Okay, so let's I'm going to split this onto the other page again. We had the same idea. In terms of constant, they might have actually been referring to constants in an equation. So we had x was greater than 8. They might want it where we, same idea as what we did before. Let's say we subtract 3 from each side. Okay. So it's like adding negative 3. It's the exact same idea. So we have x subtract 3 is greater than 5. Okay. In this case, we have a constant on both sides of the equation. So that may be what they're talking about. While with linear, they may be looking for a variable of x on both sides of the equation. So we still start with x plus 8. Okay. Now what I can do to the left side is I can split this. And we'll do it as a little side calculation. I know that x itself is technically equal to, let's say, 5x minus 4x. Okay. So I can actually replace this x with those two terms. So I now have 5x minus 4x, it's the exact same thing, is greater than 8. And maybe they've decided they want x, so to be linear on both sides. I move the 4x to the other side, so I'm left with 5x is greater than 4x plus 8. So now I have two linear type equations on both sides. Okay? And if I wanted, I could maybe add 2 to both sides, so I'd have a linear plus a constant on both sides of the equation. Where this one, we're just dealing with a constant term. I believe that's what the difference is they're looking for. Okay, here's an example of when we have an in-between. Okay, so in this instance, we're going to say x is greater than 2, but is also less than 6. Now they want a linear relationship, so we want a slope plus a constant number. So essentially, I'm going to have to multiply this by something. So let's go by 3. Okay. Now when I'm multiplying by 3, in fact, it's like a distributive property. Instead of thinking of just 2, because we have 2 inequalities, we're multiplying the 3 by all 3 terms. Right. Okay. So I'm left with.
Could it be any number or the 3?
No, just I realize 3 is a nice factor now. You want to do something different? Let's do like 5, just for the sake of it. Okay. Multiplying by 5. So we multiply each term by 5. So I end up with 10. 5x is greater than 10, but less than 30. Same idea, we need a constant. Let's now decide to subtract by 2. Is that good?
Yep.
Exact same idea. 10 subtract 2. Actually write this out for you. 5x subtract 2. And 30 subtract 2. Now, because I could actually equate the outsides of this, we will. We'll get 8. We have 5x minus 2 is greater than 8, but less than 28. And there is our linear and constant relationship while still being in between two constant numbers.
Okay, so that's the answer.
That's an answer. That's a possible answer for what we're looking for. Okay, so this one they want you to solve algebraically. They have 59 is less than 7x plus 10, which is less than 73. So 7x plus 10 is greater than 59 but less than 73. Essentially, we're isolating x. We want to know what x is. So to start off, we're going to kind of use reverse BEDMAS. Have you ever heard of that before when isolating?
Yeah.
So instead of really starting with the brackets, let's move any addition and subtraction we have first. So we have positive 10 first, so let's get rid of that first, essentially. So we're going to subtract 10
So you subtract it from the other.
from all three. Okay. So we end up with 49 is less than 7x, which is less than 63. Next step, we got to isolate the 7, so we're going to divide the entire equation. So this one we subtract the 10. This one we're going to divide by 7 everything. Okay. So we're left with 7 is less than x, which is less than 9. Okay. And in set notation, domain or whatnot would be x is a set of all real numbers such that, and that is your set notation.
Yeah.
Exists between 7 and 9. Does that make sense?
Yep.
Alright, so we have this question. They want us to find the intervals of when this is true. So what are the x values when this is true? Then we're going to solve it graphically and probably with a number line. First thing we need to do is factoring. So we find the common factor of the first set. So we're going to divide this by 2. So we have 2 by x plus 2, x minus 2. And we have a difference of squares in our last one. So we find the root of the first and the last term. Is that familiar to you? Yeah. And we have x2, x2. And when we're doing a difference of squares, we put a plus and a minus in each. We're still greater than and equal to 0. Okay. Now we have similar brackets, x plus 2, and x minus 2, and x minus 2. So we can simplify them by putting 2x plus 2 squared multiplied by x minus 2 squared greater than or equal to 0. So we have a quadratic function. Our a value, or essentially this is a positive function, right? So we know that we're going from quadrant 2 to quadrant 1. That would be quadrant 2 to quadrant 1. Does that make sense? And we can find out because these are quadratic, both of these, essentially our zeros or our roots are going to be x touches negative 2 and x touches 2. Now, do you remember the rules of when it's quadratic?
Yeah.
Or sorry, when they're squared.
Yeah, it's a double point. So
Yeah, so double point. So essentially, this is our negative 2 and this is our positive 2, let's say.
Yeah.
These are our points. So we're going to get a function that goes like this. Comes around, comes up, comes down, and comes up again. Okay. So now what we're discussing is when it is greater than 0. So essentially on our y-axis, when are we above the x-axis for this function?
So
Or when
two.
sorry, it's also equal to 0 also. So it can touch the line is what it's saying in terms of graphically.
So 2 is, or actually, when x is greater than 2.
When x is greater than 2, we're definitely increasing. But our y value is, let's talk about it. Is our y value positive right now?
Yeah.
What about here?
Yeah.
Yeah. Is it at least 0 here?
Yeah.
Is it positive?
Yeah.
Positive?
Yeah.
Positive?
Yeah.
At least 0?
Yes.
So what has happened throughout all of this?
It's always positive.
It's always positive. So essentially, from negative infinity to positive infinity, x is greater than 0, of what we found between those two. Let me quickly think for set notation. Okay, so we have to solve this inequality. Our denominator is 5 on both. I really don't want to be working with fractions.
Right.
So I'm going to multiply each by 5. So in other words, it's like multiplying this by
That's what I
5
did.
and this by 5. So what happens is these cancel out, okay? And that's it. I'm only left with x minus 4,
Oops.
x2 plus 3,
Well, I
greater
had the
than
right
equal
idea.
to, yeah, you had the right idea. You just, that's why I said you multiply by 25, because you still
Yeah.
have it with 5s on the top. So there, so we divide both sides by 2x plus 3, and when we divide, these two become 1, and we're left with x minus 4 on the other side.
Yeah, it says x greater than 5.
Bring the 4 over, minus 1, x is greater than equal